It's my pleasure to introduce you to our next speaker, Casey Martin. Casey Martin's an information security professional with a curiosity for enabling blue team operations. He's operated in all technical aspects of information security, as well as leading the consumer enablement effort as the director of security operations for some of I'm messing this up. Sorry, Casey. For some of the world's most trusted brands. Rather than mess it up any further, it's my pleasure to introduce you to Casey Martin.
Good morning, everyone. Thanks for having me. If I'm ever yelling in the mic, I'm going to try to speak loud enough that hopefully you guys can hear me. But if not, in the back, you guys can still use the headset. But again, thanks for having me out here at the conference today. Really happy to talk to you guys about how to fingerprint an enterprise network from a blue team perspective, and something what I'm calling network gravity. So real quick, going a little bit more in depth about my background and why this 12-year-old is up in front of you guys speaking. So in my 6 years in the professional world, I've been working with ReliaQuest, working with numerous customers at the enterprise level in capacities such as Director of Security Operations, overseeing our entire SOC, analyst, engineering, threat management. And most recently, working as our Director of Threat Management, which oversees our red team, threat intelligence, attack and breach simulation, and lastly, the content research and development. So how can you detect threats in your network and provide good content around that? As mentioned, I'm security focused, definitely on the blue team side of things, and I have a love for automation. I hate doing the same thing twice. So when possible, I'm going to try to script that and try to figure out how I can make that so I don't have to do that the same thing twice. I'm not great at it, but I love scripting. So, and lastly, as you guys will see here, and why I call it the bad analogy expert, I love trying to tie things back to normal human terms, try to take it to layman terms such that anyone can understand me. So, without further ado, real quick, I feel like I have to say these quick disclaimers. None of the information above, material views contained within the presentation represents that of my employer or peers. And secondly, the knowledge methods presented are based on generalizations. Everything that I'm going to say here is highly assumption-based. I think they're high probability assumptions, which is why I'm here to present. But again, you should not make authoritative conclusions off this alone. Please confirm with other sources in your environment, your network admins, your other team, sysadmins, etc. So real quick, why am I calling this network gravity? Well, one late night watching Interstellar, if you guys have seen the movie, great movie, highly recommend it with Matthew McConaughey. Had a few drinks in me, so of course I'm working and just getting creative. And they were talking about a theory, and they're talking about gravity. And it kind of took me back to black holes. And while we can't see a black hole, we can see the forces it exerts on things around it that we can observe. So if we can observe certain things and we can see how certain things are acting, we know in this case that planets were gravitating towards those black holes. And if you start calculating all of those planets around it and you start to add up all those vectors of gravity, you can start to determine size, mass, location of these things that you cannot directly observe. So while you can't observe something directly, the theory is you can see that and how it forces other objects around it. So bear with me. Through this presentation, you may see me looking a little bit like Charlie, tying strings across the board, calculating this all out. But I promise you, it's hopefully a little bit more sane than that. So my theory is that a network is no different. There are objects on the network that exert forces and generate, whether it's network traffic, processes, login requests, etc. And while you may not be able to see the true source of that activity, you can see the objects that it's acting upon and start to calculate backwards to get a conclusion of what you have for an endpoint base, a user base, etc. And a couple quick examples there, but I'll go further into those examples in a walkthrough in a second here, because that'll be the bulk of this talk. And so why does this matter, right? It's not just something fun, but it serves a purpose. All of us on the blue team side of things have a responsibility to drive visibility into our environments. If you can't see something, you can't protect it. If you don't have logs from your endpoints, whether it's the authentication attempts, your antivirus, network traffic for those endpoints, there's no good, right? You can't do anything about it. So this is really an attempt to try to drive initiative in ourselves, to try to find those answers of what exists and what can I see prior to just like going out there and asking. There's nothing worse than having someone come up to you and ask you a question, and your first answer or your first question back to them is, did you try Googling this first? And if they say no, it's very frustrating. You want someone to take that initiative. And I think the quote says it best, that Murphy's Law states that the best way to get the right answer on the internet is not to ask a question, but it's to post the wrong answer. What are some examples you've seen with this? First response, that's actually not the right law. It's Cunningham's law. Murphy's Law states that anything that can go wrong will go wrong. And I think that kind of frames up this discussion, right? I mean, you go out there and just ask a question, but they're going to look at you as if you didn't try to help yourself. And why should they then try to help you, right? If they see that you're trying to go and get 90% of the way there, they're much more going to be able to react and say, I want to help you. I'm going to get you the last 10% because it makes it look like you did some of the work. So a couple examples where that's powerful, right? New employees. You're new to an organization and you don't know what this network looks like. You don't want to be that new guy walking around asking every single question in the book. What does the network look like? How is traffic flowing? What are the egress points? Do we have antivirus installed on every asset? Poor asset management. If a single person here says they have perfect asset management, please raise your hand. I'm going to assume I don't see a single hand because no one does. It's an ever difficult challenge. And lastly, organizational bureaucracy. In my world as prior director of security operations and now director of threat management, we work with customers. Customers sometimes feel threatened that we're coming in to take their job, and that's just not the case. We're truly there to help them. We want to help them drive visibility in their organizations. But it's no different, us being a client or our clients and us being kind of the service provider. But even within organizations, very, very large organizations do not want to tell you certain things. Again, sysadmins may not want to give, security teams access to their boxes. It's going to ruin and make their jobs harder. So all these things kind of add up to making it very hard to share information in a world where we really should be sharing tons of information. So again, like I said, I want this to be a very interactive walkthrough and basically explain some of these crazy theories. So you're not just seeing me talk theory, but you're seeing it in practice. So I actually did this with a customer of ours, a real customer. It's a customer that I was not familiar with in my capacity at any time at ReliaQuest. I only leveraged public knowledge about that organization. So anything I could Google on their Wikipedia page, on their LinkedIn page, was fair game. Anything else, didn't do it. And lastly, I am going to show screenshots, and there is going to be a couple rough network diagrams from what I was able to find. But I guarantee you're not going to be able to tell the organization's identity. If you're thinking it looks like your network, it's probably because, again, these assumptions are high probability assumptions. There are things that are very common in almost every single one of our customer environments, and I could replicate this experiment over and over and get a lot of the same results. So real quick, what is the organization that I tried this for? Well, in the purpose, I'm going to call it the Acme organization. They are a retail company with 500 plus stores nationally across the U.S. They are very, very small stores. A couple endpoints per store. LinkedIn says they have roughly 20,000 employees, most of them retail, with only 1,000 of those employees roughly at their corporate location. So that's my starting point. So what am I going to do, right? I want to walk you through a couple of steps that I have time here to talk today, but I really do think this is an endless possibility. And what it starts with is you got to have access to a SIEM, which is essentially our Google for this purposes, or a Carbon Black, or an endpoint detection tool, something that has a good repository of logs, something that most large organizations have, and as a security provider, you have access to that, right? We're going one step beyond Red Team. Red Team has to work for it. We're given all of that right away, which is pretty cool. So you'll see a couple different steps that I'm going to walk through. First, identify domain controllers. Every organization has domain controllers, and if I can tell you one thing that I see common across all organizations we work with, those domain controllers are logged. It's the one thing that I feel like companies are mostly 100% on is their domain controllers. Endpoints, servers, security technologies, those are hit or miss, but domain controllers are almost always there. So working back from that output of that query of what domain controllers do they have, I'm going to take and start to identify targets authenticating to that. What domain join systems do they have? Work my way down, start to say, are those systems logging? Do I have visibility into those systems that I believe are domain joined? Start to create some percentages of what I see, what I don't see. And then lastly, kind of go towards more network traffic. Can I see egress traffic for those? Everything's connected. Can I see it talking to the internet? Do I have coverage there? And lastly, internal traffic and antivirus updates. Can I see east-west traffic between these endpoints? And lastly, do I have good antivirus coverage? You may have the best EDR in the world, but if it's deployed to 10 workstations, it's no good, right? We want total coverage. So like I said, the first step, I'm going to walk you through the assumptions and my interpretation of what I believe you can conclude from this. So the first assumption, domain controllers are one of the most commonly logged systems in the environment. And I know that Kerberos requests generate certain event IDs. Looking at that, we can start to interpret that data, right? We're going to start to see those servers logging in the environment. And based on IP address ranges, naming conventions, things like that, you can start to identify primary and secondaries, pairs and things like that. You can start to identify, based on the IP addresses you'll see further in, but maybe what server or what network. Are they in the data center? Are they in data center 2? Are they in a headquarter location? Do they have domain controllers per branch? You can start to identify all of that. And the volume of Kerberos requests indicates utilization. If you got, a couple hundred a day, it's probably not being used for the enterprise. But again, if you're getting tens of thousands, it's probably your primary versus a test system. So let's go to Splunk. Splunk is the easiest, so I just tended to use it for this one. But it's really easy to group these things together. So all those Kerberos requests, look at the output, and you can see that there's really 4 main domain controllers that I saw, just in that rough, quick query. There's 4 primaries. They all share the same naming convention, 1 through 4. So it's a good indication that they're all primary, secondary, tertiary, all in that same subnet. Makes sense. So what do I conclude from that? Again, there's really 4 domain controllers that are dominant. They share the IP address space. They share host naming conventions. But then there's 2 other ones that are rarely contacted. And I don't entirely know what those are just yet, but we'll find out. So let's graph this out. What are we starting with? Very basic. I know I have servers. Not much. But now let's build off that. I know that systems are domain joined. We want that for security. We want those systems joined, and we want to be able to see what those are doing on the network. Single sign-on, you name it. So a good assumption here, most enterprise systems are domain joined. It's a good high probability assumption. And we know that those endpoints generate machine authentications to the domain controllers. So now that we have that, we can start to break that down. Again, same thing. Similar address space kind of could indicate physical or logical barriers, right? If you have systems in the 10 dot space, it may be corporate. If you have systems in the 192 private IP space, they may be in a DMZ or some other network. Host names indicate the purpose, right? No one puts time into naming laptops. It's very rare that people put a purpose to that. But as you'll see here, one of the things I found was they just named it the Dell service tag. So it's pretty easy to say, yeah, that's a laptop or a computer just based on the Dell service tag. And again, volumes of the endpoints might indicate utilization. So let's go back to Splunk. So use the same Kerberos request, but diff it by something else. And you're going to see here I take a gross assumption, and that's that all of our networks are /24s. I know that's not 100% accurate. If you have OCD, this talk may start to bother you more and more, but I break them into /24s. It's a rough assumption that all of those things are joined in the same network like that. And you can start to see what domain controllers they authenticate against, how often you're seeing them, and where they might be. So you can see there, you start seeing workstation names. Those look like servers, what we were seeing in some of the 10 dot space. Those looked like workstation names, I think. I think I kept the account. Okay, so that's what it was. The account names were the systems logging into that domain controller, the machine accounts. We know those end with the $signs. So it's pretty easy to identify that and search on that. So what do we find? We found 4,300 unique domain joined systems based on account name. And we saw a bunch of different networks. We saw 10 dot, 172 dot, and 192 dot. And we started to see kind of how many /24s existed in each one. How highly utilized were those different networks. So we found 375 networks with very few nodes per network. Again, I know this is a retail organization with very remote branch kind of offices, stores. So you can start to say, all right, it makes sense that there's a few nodes per /24. That's probably store 1 or store 2 or store 3. And then I saw the 172 network. This had, again, a moderate number of networks. It kind of differed with naming conventions. Some had laptop Dell service tags. Some had server naming conventions, right? You might see SQL or app or something else in that. So you can identify, okay, that might be a server network. These are workstation networks. And some, you even saw more than 255 workstations authenticating to or from. Good indication there, it's a wireless network, right? People are hopping on and off, getting different addresses as they're navigating through that office, and that's why you're seeing a lot of those. So you can start to conclude, wireless networks, wired networks, server networks, store networks. Specifically, what I was interested in was CDE networks, right? If they're a retail store, they care about cardholder data. So we want to make sure that those are logging. And that'll be a big piece of where I'm going to go with this talk. And lastly, there was a 192 network that had a handful of networks, some servers, but it was really, again, there wasn't much indication exactly what it was and why it would have been separate from the 172 network and those server networks. Could be, again, a specific cardholder data network. Could be a DMZ, could be something else, but for some reason they wanted to segment it. So let's go back to that map and continue to build off. So I kind of built three logical boundaries, right? Store networks on the left, more data center headquarters in the center, and that kind of random other address space on the far right. And you'll start to see in the diagrams that there's transparency to the icons. If it's a solid dark black, it means I know I have logging for those. If it's more transparent, it's either unknown or there's not as much logging for it. So in this case, we just saw the authentications on that domain controller, that force being exerted from those workstations. We just don't know if they exist in our logging yet. We don't know if we have information from those, but we know that we need to start providing controls around those. So let's go see if we do have those systems logging. We know that endpoints, the logins, are logged directly and locally to those systems. We know that, depending on your verbosity of logs, you might be logging process creation events, all sorts of different things, right? So we know that they generate logs just as much as, honestly, domain controllers. But the organizations really don't log endpoints. It's very difficult to do. It's very expensive for your licensing. So we know that's generally a weak spot. But again, knowing there's a cardholder data environment, we want to make sure that they have that logging because that is a compliance requirement. So how do we interpret that? We know what workstations we expect to exist, what servers we expect to exist. If we intersect that with what logs we actually have from a Windows and Linux perspective, we can start to identify gaps, right? If we know stuff is logging, we expect stuff to exist. The difference there is what's missing. So let's do the same thing. In Splunk, you can kind of search on a couple of the indexes, look for Windows logs, look for Windows logs, or Windows and Linux logs, and start to identify just that source host that's logging. In this case, you end up seeing that in the query there was some 2,000 systems that we saw logs for, and they all had really, really odd naming conventions that I didn't see prior in the machine authentications. And that's not the exact one. I had to sanitize it a little bit for the purpose of the demo, but it was pretty clear to me that there was a number, another string, and then another number. And just based off our experience, we know that that might be, a way to track those assets. So in this case, what I believe it to be is a store code. That string represents the point of sale system. And then the digit after that was likely the number of system it was, right? The register number, et cetera, at that location. So that gives us some good information, right? These things that I believe are cardholder data and systems are logging, but they're not domain joined. Not at least to the domain that I know about. So that right there, I started to identify a gap. All right? That's something we can work from and add visibility to for that organization. But I saw nothing of what I expected to exist. None of the servers, none of the corporate machines, none of the other store systems that I expected to be there were there. So there's two really store systems. There was one that had a normal laptop naming convention, and then there was the ones you guys just saw that had point of sale like naming conventions. It was really weird though. None of those were logging. None of them. Which is unheard of really. I mean, you usually see a subset, but nothing was there. So the only thing we knew that was logging and domain joined were those domain controllers. So really what did we find? Again, none of that was logging. And we started to find a hint that all of those point of sale systems that were logging existed in the same 10 dot space as the other ones, which starts to make sense, right? It confirms my theory that that's a store location and they probably differ the stores by subnet, right? And so then I took the naming conventions and uniqued all of those. And there was roughly 550 store IDs, which makes sense. Going back to Google, we knew they had roughly 500 stores. So it maps up, it starts to make a lot of sense. And then you look at those system identifiers, and there was less than 10 per network. So that makes sense again. Few stores have more than 10 registers, unless it's a big box retailer. But again, all of that started giving me more context about those environments, and ultimately led us to this map. It's pretty much the same as prior, but you're going to see the box on the left, the bigger box. That kind of indicates the domain that we know about. And then there's these random systems off to the right. Not authenticating. I did a quick check. I didn't put it in the slides, but they're all doing local authentication for their CDE POS systems, which is interesting. But it's good they have those logging, so they do have that kind of information about it. So now we have a rough understanding of what their endpoints and servers look like. But now we want to know, where is this traffic flowing? How do those stores connect back to the data center? Do we have visibility into those store systems? Some organizations for those branch locations egress traffic directly out through that store and only pipe back to their corporate what they need to for services. Some tunnel everything back because they want that visibility. So we want to see how that was laid out. If, for example, they are putting firewalls at all these branch locations, do we have those logs? Do we have visibility into that network traffic going in and out? With an ever-evolving, command and control infrastructure going on out in the world, we want to know if they're beaconing back, we can see those logs and we can detect that. So let's go to egress traffic. Again, assumptions. Everything talks to the internet nowadays. Everything. Refrigerators, toasters, you name it. So we know that, and then we know, again, based on this being a retailer, there's a couple different methods they could bring that traffic out to the internet. Could bring it back to the data center or directly out through the stores. So we're going to start to interpret that data and start to see what is logging, what's not logging. If we do not see egress traffic for a network, it's likely we're missing a device, right? It's not logging. It's, again, another gap in our network. So let's go back to Splunk, run a query. We knew that they had two devices logged into Splunk. They had an ASA device type and they had a Palo Alto device type. And we started to do, all egress traffic. Again, I'm taking the broad assumptions. I'm just taking /24s, but I started to look at all of that traffic going out and said, do I see traffic for every single network that I expect to be there? And sure enough, I did. We saw all of that traffic going out, so it's good. We have visibility into every single system in egress traffic. I filtered a little bit extra and just made sure that I was seeing HTTP traffic, HTTPS traffic, DNS traffic, and all of that was coming back through what I assumed to be the data center. So that's good. We have visibility there. That organization isn't missing anything. But one of the things I thought was weird is that the Cisco ASA and the Palo were seeing the exact same sets of traffic. No difference. If you saw a packet going through one, you saw it going through the other. And that led me to, again, my initial thought, what we commonly see in a lot of organizations is that they may use ASAs internally to terminate the store connection back into their network. And then, some sort of Palo at the edge that's going to filter that out. But it was a little weird because, again, I started to see every single packet. So this was my assumption kind of coming out of that last iteration. But I wasn't quite certain that was it until this next step. So again, we know we have good external visibility, which is really good. But now internal visibility. This is a concept that I feel like most organizations do not do well. They have very little east-west traffic. It can be expensive. It can be expensive to log. It can be expensive to put those devices in place. So oftentimes we just see egress traffic for organizations. But let's run a check anyways. So we know that few organizations have this. But if they do, again, we can start to diff all those networks. Is the 10 store networks talking to 10 corporate, 172 corporate workstation networks, 172 corporate server networks, and start to identify which systems these networks are talking to, and if we see it or not. Especially with a CD environment that you do want strong segmentation. So let's run the same query. We know that those devices were logging, ASAs and Palos. So let's rerun the same query, but now just look internal to internal traffic. And I know it's pretty hard to see, but you'll see I just roughly did 10 dots for the screenshot. And you'll see that we have visibility from every single private network to every other private network. So everything that's talking across those three different main environments, right? The 10 dot, which I believe is stores, the 172 dot, which I believe is their corporate headquarters data center, and the 192, which, again, I'm still unsure if it's like a segmented CDE network or a DMZ. We have all that traffic, which is awesome. And furthermore, on the far right, I kind of put some interpretations of counts. How many unique /24s did I see per, again, rough location, stores, headquarters, DMZ/CDE. And so it's really interesting that, for example, between the 10 dot and 10 dot, which are the stores, I see everything. Between the 172 dot and the 172 dot, I see everything, which is really weird. They might have complete internal visibility. They might have these PALs or ASAs at their core, and everything's going through them for east-west visibility. That's unheard of, but really cool. As a defender, that gives us a lot of opportunities to start creating detections for abnormalities in the network. And again, the same thing we saw was Cisco ASAs and Palos were seeing exact identical traffic between them. Which led me to one conclusion as I was talking to one of our network guys. Are they migrating? And it turns out they were. I think they're in the middle of a migration away from ASAs to Palos at that core. But we could tell that because there was one little keyword in one of the Palo zones for vWire, which, again, I'm not a network guy, not an expert on that front by any means, but it's basically something that spans the traffic between the two devices and allows for kind of that intermediate, both devices are in place. You can map over the policies between one and the other and then rip out the old device. So I'm going to go ahead and modify my map a little bit. So I think everything's connecting to those ASAs and Palos. Again, you'll start to see in the store environment, as we were looking at specific traffic between the 10 dot networks, I never saw traffic cross between what I thought was the point of sale systems and the other laptops in that environment, which makes sense. They have a laptop by their franchise information. CD environments completely separate and segmented. So that's good. And now I'm starting to create some physical boundaries, right? The stores are always obviously remote, 500 plus satellite offices, satellite stores. But it looks like they have that one corporate environment. And again, this is really useful because as we're blue teamers, you can start to create rules, right? If you expect, and now you know what those cardholder data networks are, you expect to never talk to a non-cardholder data network. You probably don't expect your point of sale systems to be talking to your corporate laptops. That's just weird. But there's probably some applications in that server network I was talking about that would make sense. And again, you'll start to see here that the devices I know that are logging, again, more straight black. And then there's some devices in the network that are not as solid and they're transparent. And that's because I don't have logs from those systems. So I have domain controller logs. I have all internal, all egress logs for traffic. And I have the CDE point of sale systems logging. So we know that there's some systems missing, right? We know that there's gaps on the systems. Well, are we looking at those a different way, right? Do we have endpoint detection coverage for those systems? So a good assumption is that organizations have an endpoint technology. They have an antivirus, they have an EDR, they have something. And those technologies generate traffic for signature updates, generate traffic if they're sending out data for correlation in the cloud or on-prem. And so I know that that's there. If I'm seeing those updates, it means that rough network that I see it originating from has some sort of EDR in that network. So let's go back and run another query. In this case, they did have an EDR solution logging to their Splunk. Took that EDR, did a quick Google. Obviously, it's sanitized here, but they had a domain for their updates. So let's go search for all traffic to that, now knowing that I see every single network egressing, so I have that visibility. Let's use that output as input for this query. And we can start to see that there was tons of networks. I didn't let it fully run, I think, but there was roughly 1,300 networks that we saw generating that endpoint traffic for the updates, for the signature updates. But what we didn't see was 80 networks without endpoint coverage. It was mostly the non-CDE environments of the stores, probably just some local laptop they tossed out to those guys, so it may not be as critical, right? We saw earlier that those non-CDE environments can't talk to the CDE environment, so if you're going to accept some risk, that might be a good place to not increase your license. But the weird part that I saw was there was some application server, there were some server networks that had nothing. No EDR, no logs. And that's a little concerning because, again, knowing that it's a retail organization, they could be storing PII, could be storing cardholder information on these systems. And if we don't have any visibility into it, local logs or endpoint, we're really limiting ourselves. So I kind of dropped a little antivirus logo for the different networks, and you'll start to see that again. There was like a random network that I think was some wireless networks. Everything on those networks were sending updates. So we had what I believe is probably corporate laptops, EDR covered. CD environment on the far left, all 100 of those, all those networks covered. The non-CDE stores, or the non-CDE store locations, those were spotty. Some had them, some didn't. Not really sure if they're in the middle of rolling that out. But then when you come back to the corporate location and you look at those servers, there's near nothing. No coverage. So that's a big gap for us that we can go back to that customer and without even asking them, hey, how far along are you in your EDR deployment? We can almost go to them and tell them, right? Going back to that Murphy's Law, Cunningham's Law example, you can go back to them and say, hey, I don't see this. Can you guys confirm? And they could be like, yeah, no, you're right. Like, we haven't found that far, things like that. And there's other cases that I think, this is one example, but I tested it in a couple other environments. And for example, with bigger branch offices, sometimes again, they put that firewall at the edge. Well, if we see domain authentications from endpoints, but we don't have endpoints logging, but we know that network exists, and then we look for egress traffic, and we don't see any egress traffic from that network, we now have a pretty good conclusion that they aren't logging some egress device at that location, and they're not logging those devices logs either. So again, a blind spot in that branch office. So again, there's many iterations of things that I think you could search for. Again, going back to the gravitational forces that devices exert, that we can see through other devices we can observe from. And all of that can be put together to start to draw very crude maps and start to identify weaknesses in our visibility, areas of improvement, where to prioritize, and things like that. So for the sake of time, I know I'm coming up here with 10 minutes left, but I want to talk through a couple other theories that, I think we could go explore and test. Let's say we do have these server logs or endpoint logs. If you're looking at login processes, you can start to map what that server is. If you see logins from W3WP, it's probably got a web front end to it, right? So now we got a web server out there. We can start to map all of our web servers. In this case, we have total east-west visibility. So imagine looking at all of the traffic on that network for known services. I just threw up 1433, which is for MS SQL. Now you know all your database services. Going back to web, let's say it's not running IIS, but it's running Apache. 80 and 443, you'd start to find those web servers. Going even further, right? You might have, again, if that network was a DMZ network, and you see inbound traffic to 80 and 443, now you know your internet exposed systems. And you can start to really use that, again, to guide what protections do you have in place, what can you actually see centrally logged in the environment. And lastly, I don't think it just applies to networks, but I think it could apply to user base. Naming conventions for users are often pretty verbose. They give you a lot of information about what's going on. So if you're looking at domain joined authentications, you can start to look at those usernames and start to deduce their naming convention. A lot of organizations will throw SVC in front of a service account, or DA in front of a domain admin account, or SA for system admin. And then normal accounts may just be first initial last name. So we can use that to start break down user groups and what users are. And then if we have normal users, and from our steps prior, we start to identify applications that are running on those systems. Let's say you see only a subset of users hitting this server. Well, now you can kind of join those users into a department, right? If they're hitting some sort of server and that host name has finance in it, or if it has marketing in the name, or even with server naming conventions, and then you only see a dozen users logging into that, it's a pretty good bet that they're either admins for that system or they're the users of that system. So if it's a financing application, maybe they're finance users. And you can keep using that information to drive further and further visibility in your network. Again, I really think the number of small pieces of logs, artifacts and logs that we can observe will allow us to really explore that network, figure out what's out there, and take a little bit of initiative on our own before just going out there and asking, what servers do we have? So where do I think I can take this next? Automation is a big one. As I mentioned in the first slide, I'm a huge fan of automation. A lot of these queries are very applicable to almost every single environment. Obviously, Splunk, you can bring logs in a couple different ways. So you might have to adjust some fields, but whether you're using QRadar or Logarithm or you name it, you could start to use this data, extract it with the query, and start to pull together a rough map. But the one hiccup I think we'll encounter is quirky pieces that we don't expect. In this case, there was a couple things that just threw me off, and there wasn't enough information for me to be able to determine what that system was. In the case of the ASAs and Palos, it was weird that I saw a duplication of traffic, because that's a rare occurrence. The server network, we never really concluded whether it had internet public-facing systems or CDE systems that was only talking to it. But I think you could go back and further look at that traffic and analyze it. And again, the last part is really just continued testing this. I've tested it in a couple different environments and gone back to the engineers, the threat management, content developers for that account. And I've basically brought them this map. And sometimes it's spot on with what they expect. So it kind of it proves that it's beneficial and works. And in some cases, I take it back to that developer, that engineer, and I go, hey, I think they're missing this device. I think they're missing this device. You could start to build rules around this based off I only see these networks talking to these networks. And it's things they didn't even know about it. So I really think even within your own organization, you could start to identify gaps that you're seeing through these logs and bring it back to that department. Hey, I see finance people logging into the server, but I'll see this other user talking to the server. Does he belong? Does he belong on the system? And I think you can start to bring that information and things that they typically aren't observing, and really start to ask questions around that. So, with that said, I mean, that's really where I'm at with the project. I'd love to get you guys' questions, see if you guys have any thoughts, additional things that maybe I could have tested or did test and just didn't get to include in the slides. But again, if you guys have any questions. What specifically for the Wi-Fi segment? Like, what are you looking for on that? Yeah, so in this case, Yep. So the question was, is there any way to know who's accessing the Wi-Fi network, wireless network that might not be expected? In this case, if I'm looking at it and I'm trying to figure out who's on my Wi-Fi, it's probably not a domain joined system, right? If I'm bringing an outside device to connect to that Wi-Fi, it may not be generating the machine accounts to the domain controller, so I wouldn't have that visibility. I didn't go down that route of looking to see if they have whatever system is handling authentication to Wi-Fi, whether it's pre-shared key or individual access. I didn't check that, but you could start to say, hey, like, are there devices, if you have those logs, are there devices connecting to wireless that don't fit the normal naming convention or user convention or things like that? So I think there's areas where you could do it. Again, you'd have to see if that logging is there and kind of keep working off of that, but I think it's possible.
So do you see this as something that so if we were to implement this to our organization, say we had Splunk, do you see this as something that a specialist does as a manual process, or do you see something like, do you foresee building out kind of automation around this, like a Splunk app or dashboard to do some stuff?
Yeah, so the question is, like, is it going to be manual? Is there the ability to build out dashboards, queries, and Splunk to make it repeatable? I want to hope so. I really do. I think that a lot of these assumptions, theories, and interpretations are general enough that it applies to most organizations. It's tough. Right now, it's a very manual process. Again, just as I'm proving out the theory, but I think there are cases where we could put it in a dashboard and drive that visibility and say, hey, again, one of the things that I saw in one environment was an organization had acquired, in this case, it was a hospital network, and they had acquired a hospital that they weren't even aware of, but they ended up joining those systems into the domain, weren't logging those systems, and then weren't logging the egress point. And that organization didn't even know they had that hospital in their network until we basically started looking at the forces coming across from the workstations and then realized there was gaps all across the board from that central now, network. They didn't see that acquired network in their monitoring tools and their security tools. In front, then we'll go behind.
You see companies doing these type of obfuscation
So the question is, do we see attackers, or do we see companies trying to obfuscate host names, usernames, et cetera, to try to make it harder for the attackers? Yes. Usernames, I think a common one that probably maybe 30% of the time, we'll see like a user ID. So it doesn't tell you who it is, what role it's in. That can make it hard, right? Versus a username that you can go search on LinkedIn. Host names, rarely, honestly rarely. The inconvenience for them not knowing what that system is, I think is probably more of an inconvenience than it's worth in obfuscating it. So I don't see it often. I see it as more like they'd be making their own job more difficult, so they aren't typically doing that.
I was going to ask, when we're looking at the Cisco ASA logs, you have, from your standpoint, do you have any visibility just what is actually logged on the Splunk at that end? Having seen that implemented, there's a lot of things that oftentimes are not being logged. There's a lot of non-privileged information, but there's some very valuable information.
So I'm going to go ahead and plug my colleague's talk at 3:15. Kevin, 3:15? Is it? So Kevin will be doing a talk at 3:15. He covers that in depth. All sorts of logging failures, how you can know if something is logging. If it's logging, do you have all the right logs from that device? If you have all the logs from those devices that you know about, are there devices out there that, are just not capable of detecting that threat? For example, ASAs aren't protocol aware, things like that. I would go to his talk for more, but yeah, from what I could see, I think they were logging builds, teardowns. They had some ACL hit logs coming off those devices. So I think I was seeing everything. But again, in your organization, I think you could start to tear back the layers and find if there's gaps or not. Yep.
This is for the product that we want. We have the custom ones, which, well, so-and-so wrote a custom one for this. Well, sure enough, they wrote this. And so-and-so left. So now we have no clue what it does, what it actually belongs to.
Yeah, so
there's a big trade-off in that.
No, I agree. I think me and my organization are a unique spot, right? Because we work with near 200 enterprise organizations. I think in a more like a single company approach, if you are the security administrator for one company, I think a Splunk app makes sense. For us, I kind of see us taking it and putting it into our product in more of a hunt. So using the queries and the APIs that we know exist with QRadar, LogRhythm, Splunk, and writing that such that kind of our product will translate those queries into each technology's query, bring back that data, and on our side can visualize that. But yes, I think there's a lot of options that we could go down. Even like a local Python script, you could do that and dump it to some sort of JSON structure or something. It's got to be an approach. There's got to be a good approach. Any other questions? All right. Well, thank you all for sticking around for the talk. We appreciate it. Have a good day.